Okay, student, good morning to all of you. Myself is Dr. Santosh Choudhury, reader in chemistry. Last class, in class number 8, what I mean, alcohol, ether in class number 8, we discussed about the some characteristics of phenol and some uses and some introduction about the ether. Ether is nothing but the dialkyl derivative of water, means the two hydrogen atom of water molecule replaced by the same or different alkyl group, or alkoxy derivative of alkane. The hydrogen atom of alkane molecule replaced by the OR group, that is called alkoxy group. Today we will discuss the method of preparation, some important physical and chemical properties, method preparation of ether, and use some uses. We will discuss these things today, and after discussing, the chapter will be over. Now, method of preparation, the ether can be prepared from two ways. From alcohol. Particularly, we are doing the from primary alcohol. What is primary alcohol? Primary alcohol means the alcohol which possesses CH2OH group, that means RCH2OH. This is your primary alcohol. When primary alcohol treated with sulfuric acid at about 140 degrees C, you will take the starting molecule, two molecules, it gives to ether RCH2O CH2R plus H2O. This is called ether. Simply you can say RCH2OH plus OH CH2R. This is one molecule of alcohol, this is another molecule of alcohol, and you treat it with, suppose, concentrated sulfuric acid at 140 degrees C. What is the function of this concentrated sulfuric acid? It can dehydrating agent. It is dehydrating agent. It can remove a molecule of water from here, dehydrate loss of molecule, it become RCH2O CH2R. This is your ether. Okay, and the secondary and tertiary alcohol you not use for preparation of ether due to some reason when you go through the mechanism. Suppose if you take ethanol, what is ethanol? That is CH3 CH2OH. This is called ethanol. Two molecules and heated with concentrated sulfuric acid 140 degrees C. What product is this? Is your R. This is your R. So it gives CH3 CH2O CH2 CH3. This is called ethoxy ethane, or you can say diethyl ether plus water. So next question, how it is taking place? This is your sulfuric acid, provide you H plus ion, HSO4 minus ion, and this is your alcohol, and this is your proton from the acid, and this one is protonated. As a result, form CH3, CH2, OH, OH2 plus. So, in the second molecule of alcohol, that is CH3, CH2OH, to this molecule this get lost molecule of water. This became CH3. Okay, you don't lose. Now this one CH3, CH2, OH2, positive charge, and this will be attached to here. So what will happen? This will lose a molecule of water. This became CH3, CH2O plus H and bonded to CH2, CH3. And now this electron come to here, it lost molecule of H plus ion. This became CH3, CH2O, CH2, CH3. This is your ether. This will attack to here. You get last molecule of water. Okay, students. So this undergoes one type of SN2 reaction. As you know, SN2 reaction does not favor by secondary or tertiary alcohol. That's why you are always prepared to take what? Primary alcohol. So this is one of the method of preparation of ether from alcohol. We come to next method. Mind it, in same method we cannot prepare the aromatic ether because in aromatic ether we require phenol. Phenol, the carbon oxygen bond is double bond, it cannot break so easily. Next come to from alkyl halide. From alkyl halide we can prepare the ether by two methods. One is called Williamson synthesis. In Williamson synthesis, the alkyl halide, this is your primary alkyl halide, react with sodium alkoxide. Because H means hydroxide, R means alkoxide, it gets lost molecular what? NaX, it became RCH2 O R test. This is your ether. And we will not take the secondary or the tertiary alkyl halide is not used for the preparation of ether as this means secondary tertiary alcohol alkyl halide undergoes elimination reaction to form what? Alkene rather than doesn't never form what? Ether. It always undergoes elimination to form what? Alkene. That's why you are not prepared to take the secondary or tertiary alkyl halide. Okay, suppose you take methyl bromide CH3 Br plus C2H5ONa. This is your sodium ethoxide. What product will get? What product? The NaBr here Na. This means the Br is substituted by C2H5O minus. This became CH3O C2H5. This is your methoxy ethane plus Na. Suppose you take ethyl bromide, you sodium ethoxide, what gives it is? It gives you C2H5O C2H5 plus NaBr. This is called ethoxy ethane. It one type of also SN2 reaction. SN2 reaction. Suppose you want to prepare this is your sodium phenoxide that react with suppose ethyl bromide. It gives what? The sodium and NaBr get lost here, so it became what? Benzene ring O CH3 plus NaBr. This is called anisole or methoxy benzene. Okay, students, suppose somebody is asking a question. So how can you convert the ethyl alcohol to dimethyl ether? Suppose C2H5OH, we have to convert this C2H5O C2H5. First is you can treat it with concentrated sulfuric acid and make 140-degree temperature. So this gives you this one, dimethyl ether. But another way, suppose the concentrated sulfuric is not given to you, means you prepare the diethyl ether, the absence of sulfuric acid. What I can do? So you can this one. First I will make it ethyl alcohol to ethyl bromide and ethyl alcohol to sodium ethoxide. You know, in a alcohol chapter we will discuss already these characteristics. And after making these two, what is ethyl bromide and sodium ethoxide, you react to give the ethyl ether. Okay, so what I will do first? This is first converted into what compound? Suppose this is treated with phosphorus plus bromine. So this OH group became C2H5 what? Br. Now again this is treated with metallic sodium. this H became, because acidic nature, this became C2H5O Na. Now these two are combined to give what? C2H5O, C2H5. This is ethoxy ethane. This is one way, and this is another way to convert ethanol to diethyl ethanol. Suppose I want to prepare this type of ether. Suppose what is now this ether? Tertiary butyl methyl ether, or what you can say 1, 2, 3, 1, 2, 3, not 1, 2, 3. That is methyl group, methoxy group is that. So you can say 2-methyl, 2-methoxy propane. This is 1, 2, 3, 2-methyl, 2-methoxy, 1, 2, 3 propane. So how can you prepare this alcohol? How I can prepare this one? We can say, sir, you will take, this side is halide, this side is alkoxide. Or this side is your alkoxide, this side is your bromide. So you will take the two chances, that is, one you will take CS3, C, CS3, CS3, Br plus CS3, ON. This may react to give that compound. Somebody say, no sir, this way, CS3, C, CS3, CS3, ONA plus CS3, Br. Between these two, which is correct? Or both are correct? You see, this is your tertiary alkyl halide. You know the what alkyl halide used for the preparation of ether in Williamson synthesis, that should be primary. It is not the secondary, it is not tertiary. If this one treated with sodium ethoxide, it is a very strong base. It is a very what? This is a strong base. In presence of a very strong base, it undergoes elimination reaction. It forms CS3, C, CS3, double bond, CH2, this is form isobutene. It does not form the ether, because this undergoes elimination reaction. So by taking tertiary butyl bromide, we cannot prepare this ether, that 2-methyl, 2-methoxypropane. We cannot prepare this, because the tertiary alkyl halide undergoes elimination reaction in presence of a strong base. As a result, to form an alkene. What alkene this is? This is your isobutene, or what is the name of this compound? 1, 2, 3, 2-methyl propane. Okay, student, and to prepare this compound, this is the appropriate reagent to form sodium tertiary butoxide react with ethyl bromide. It gives this ether, that is 2-methyl, 2-methoxypropane, or tertiary butyl methyl ether. Okay, students, these are the questions. Why we are not listing this one? Why this is not taken? Why this one taken? Okay, students, these are the method of preparation of ether from alkyl halide, and another method is there. The alkyl halide then heated with dry silver oxide. That is alkyl halide, that RX. This is your alkyl halide heated with silver oxide, dry silver oxide. Dry silver oxide. You take another molecule and the halogen atom gets substituted with oxygen. It gets lost molecule of ROR, means ROR. ROR plus 2 molecular AgX. This is your ether. Suppose you take ethyl bromide, heat with dry silver oxide, so 2 molecules. What is ROR? That is C2H5O C2H5 plus 2 Ag. This is diethyl ether. Okay, student, these are the various methods of preparation of ether. You can prepare aromatic ether, that is anisole. The anisole can be prepared when there is sodium phenoxide, that means phenol treated with sodium hydroxide to form sodium phenoxide. This sodium phenoxide heated with alkyl halide, aliphatic alkyl halide to form aromatic ethers. Next come to the properties. Okay, students, these are the method of preparation of ether. Next come to the properties. The lower member ethers means dimethyl ether, diethyl ether are colorless gases. Higher members are liquid. Ether are soluble in water due to formation of hydrogen bond with water molecules. So this is your ether. You know, ether has a angular shape, and water also the angular shape, and result to form, this is partially negative charge, this is partially positive charge. Okay, and this will form a hydrogen bond. So result form like this one, R O H O. This way it will continue. This is our hydrogen bond. That's why ether are soluble in water. Generally, ethers are non-polar. There is no charge separation, very small charge separation. That's why the boiling point and melting point of the ether is less than that of the alcohol. Because in alcohol there is presence of the OH group, and the OH group can able to form intermolecular hydrogen bond. Means the molecules are associated, that is alcohol molecules are associated together by what? Hydrogen bond, associated together. But such type of bond is not present in ether because oxygen not bonded to hydrogen, is bonded to an alkyl group. That's why ether possesses low melting point, boiling point as compared to the alcohol. So can you say as compared to alkane, which will alkane and ether, which will have more boiling point or melting point? No doubt. The oxygen is somewhat polar. Oxygen is more electronegativity. That's why the molecule is somewhat polar, and pure alkane is totally non-polar. In that case, the ether possesses little bit higher melting point, boiling point as compared to what? Alkanes. Okay, students? And ether generally used as a non-aqueous solvent, non-proton aprotic solvent. Aprotic solvent is the solvent which does not provide any proton, that's called aprotic solvent. Okay, now come to the Chemical properties. Chemical properties. In ether, mind it, the dipole moment of ether not equal to 0 because angular set. In ether, that is the oxygen, carbon, carbon bond is there. And the dipole moment of this molecule is not equal to 0 due to angular set. If the dipole moment is not 0, so it means little bit polar molecule. Polar in nature. Which bond is polar in nature? The bond, this bond, polar in nature, this possesses fractional negative charge, this carbon atom possesses fractional positive charge. So during the reaction of ether, particularly the carbon oxygen bond get cleavage. That is, during the reaction ether, the carbon oxygen bond cleave. The carbon oxygen bond is what? Cleave. The ether generally react with halogen acid, particularly HI. So we will discuss the reaction of ether with HI. That is reaction of ether with hydrogen iodide. There are two cases we will discuss. One is cold concentrated HI. Another case is hot concentrated HI. You know, HI is a strong acid. You dissociate to form the H plus ion. So the HI dissociate to form H plus ion and I minus ion. Now this is your ether and this is your H plus ion, and the lone pair electron of the oxygen atom of ether is protonated. As I am protonated, it gives you R O positive. This is R, this is H. This is called protonated ether. What will happen? The protonated ether, the presence of a nucleophile I minus, the I minus will attack to the alkyl group, either this one or this one. So this, suppose this is the attack to this alkyl group. You can say, sir, if there is presence of two different alkyl groups. In case of unsymmetrical ether, it contains two different alkyl groups. Which alkyl group it will attack? This is a question. Very good question. So the I minus will attack to the alkyl group having less numbers of carbon atom. Suppose this one is less number carbon atom. What will happen? When it attack, this electron pair come to here, it became Ri plus, what will happen? ROH, and this is form alkyl halide, and this is form alcohol. Okay, students, if there is a symmetrical ether, then no problem. One alkyl group form alkyl halide, other one form alcohol. Suppose if you take dimethyl ether, when treated with cold concentrated HI, so naturally it gives two molecules, that CH3OH plus CH3I. Suppose you take diethyl ether, that is C2H5 O C2H5. This is your diethyl ether. What product will get? Can you write? You can get a molecule of ethyl iodide and another molecule of ethanol or ethyl alcohol. Can you write this? This is A plus. You can write what is A, what is B. But in case of the unsymmetrical ether, what is unsymmetrical ether? The ether molecule have two different alkyl group. That's called unsymmetrical ether. In case of unsymmetrical ether, suppose you take CH3O C2H5, when treated with cold concentrated HI. Now the question arises, which alkyl group became alkyl iodide and which alkyl group became alcohol? You know, we have discussed in the first reaction, the iodide ion of HI will attack to the alkyl group which possesses what? Which possesses less number of carbon atom, less bulky group. Between these two, the methyl and ethyl group is less bulky. That means, this is your methoxy methane, and it is an unsymmetrical ether. So the HI, the I will come to this side and H will come to this side. When this bond break here, this is I, this is your H. So this became CH3I plus C2H5OH. Suppose you take anisole. What is anisole? C6H5OCH3. This is called anisole. That is a aromatic ether. When heated with cold and concentrated HI, what will give you? The bond is break here. This side H, this side is your I. This became CH3I plus C6H5OH. This is your phenol. But one thing is there, the alkyl group, the phenyl group or a primary alkyl group, if the alkyl group is a secondary or tertiary nature, then the iodide ion will attack to the more bulky group, that is the secondary and tertiary alkyl groups, not the less bulky group. Are clear? Tamane, if the ether is a two alkyl group, if one of the alkyl group is a secondary or tertiary nature, then the iodide ion will attack to this what secondary tertiary alkyl group, because the tertiary and secondary alkyl group is more stable. The secondary and tertiary alkyl cation, carbon ion, is more stable. Okay, that's why if the ether is unsymmetrical, having that secondary tertiary alkyl group, suppose CS3, CH, CS3, O, C2H5. Can you name this compound? This compound is ethoxy. Ethoxy propane, when it heated with cold and concentrated HI, what will happen? Now the bond will break here, and this side H, this side is your I. You see, this is a bulky group as compared to this one. But as it is a secondary nature, and the carbonium ion is more stable, that's why the electrophile, that's why the nucleophile I minus will attack to the most of carbonium ion at this side. The product is CS3, CH, CS3I plus C2H5 OH. Okay, students, these are the reactions of ether with cold and concentrated hydrogen iodide. The reaction of cold and concentrated HI with symmetrical ether and unsymmetrical ether. In cold condition, it gives the mixture of alkyl iodide and what? Alcohols. And in case of unsymmetrical ether, the I will goes to the alkyl group which possesses less number carbon atom. But if the ether possesses a secondary or tertiary alkyl group, the I will goes to the side which are secondary or tertiary alkyl group, not the less bulky group. Okay, students, this is the reactions of ether with cold and concentrated hydrogen iodide. Let us see reaction with hot concentrated hydrogen iodide. In hot concentrated iodide, that is ROR, that react with hot concentrated HI. Note out first it gives you Ri plus ROH. You know this ROH further react with HI, it gives Ri plus H2. Means the ROR ether, symmetrical or unsymmetrical, there is no question. When heated with hot concentrated HI, you take the two molecule, so it gives two molecule of Ri plus H2. So suppose I will take dimethyl ether, two molecule, when heat with concentrated HI gives what? It gives the two molecule of HI plus H2. Suppose if you take CS3, okay, CS3 OC2H5, you put a two molecule, heat with concentrated HI, gives what? It gives the mixture of CS3I plus C2H5I plus H2. You see the reaction quite different, cold HI, hot HI. But when you take anisole, what is anisole? That is C6H5O CS3. This is called anisole. That is, this is your phenyl group. OHO CS3 group. Then heated with concentrated HI, what product it gives? You see, this is does not give two molecules of alkyl iodide, because the phenol never does not convert to alkyl iodide, means phenyl iodide or iodobenzene so easily due to the carbon oxygen is stronger. That's why it gives the only methyl iodide plus this one. This is your phenol, and this is further doesn't get with HI due to the carbon oxygen bond stronger. So this gives you a mixture of methyl iodide and phenol. Okay, students, I will give some question. You may solve this and identify the product. Now the question is identify the product. Suppose you take CS3OC2H5. That is, you can say methoxyethane or ethyl methyl ether. This is treated with cold HI, treated with hot cold concentrated HI, treated with hot concentrated HI, and suppose it treated with steam. Steam का मतलब water. Water dissociated gives H plus and OH minus. So it gives the product A plus B. Here gives only A plus B plus H2O. Here gives A plus B. You may doubt here because this is your CS3OC2H5 plus H2O. मतलब you break this one, which will not break. This body suppose break here. This side is your OH, this side is your H. That is CS3OH8 C2H5 OH3. Okay, students, another one. Suppose if you take anisole, you treat it with cold concentrated HI or hot concentrated HI, it gives the same product A plus P. Another question, CS3, CH, CS3O, CS3 is given to you. Suppose you heated with cold concentrated HI, it gives A plus B. Suppose this one also treated with hot concentrated HI, it gives A plus B. And you can write here C plus D. These are some reactions of ether, and we have to study some specific character of aromatic ether, that's your anisole. What is anisole? That is your electrophilic substitution reaction of anisole. What is anisole? Methoxybenzene is called anisole, and this is your anisole, this is your methoxybenzene. You see, methoxybenzene, this part maybe shows the character of ether. But this benzene ring undergoes electrophilic substitution reaction. What are the electrophilic substitution reaction? The electrophilic substitution reaction is halogenation, sulfonation, nitration, pedal cap reaction, just like as shown in case of phenol. So the electrophile, the benzene ring of the anisole shows the electrophilic substitution reaction, the electrophile substituted with position. The electrophile substituted either ortho of phenol, and next class students will discuss about some chemical properties. In chemical properties we will discuss the acidic nature of the phenol and the acidic strength, and what type of phenol is more acidic and what type of phenol less acidic than the original phenol. And we will discuss some reaction, the reaction of phenol due to the OH group, the reaction of the phenol due to the benzene ring, and some name reaction, just like your Riemann-Tiemann reaction, which is most important in phenol, and you will discuss some certain Baumann's reactions. So many types of reaction are there. Okay. Today we will discuss what is phenol, and phenol is nothing but the hydroxy derivative of benzene. The hydrogen atom of benzene nucleus gets substituted by what? By the OH group. And we have to name the phenol in common system as well as in IPEX system. In IPEX system, the OH group, the carbon bearing the OH group termed as 1. That is, according to the other position, we can name this phenol. And we will discuss the method of preparation of phenol. Phenol can be prepared from benzene diazonium chloride. It can be prepared from benzene by various methods, by sulfonation, chlorination, Rajik's process, and by forming the cumene. So many methods are there. And phenol can also be prepared from chlorobenzene, and that process is called Dawes process. And we will discuss some physical properties of phenol. And phenol is known as what acid? Commonly known as what acid? Carbolic acid. What acid is called? Carbolic acid. Okay, student, this much today. Thank you. H2SO. And this is the mechanism of the dehydration of alcohol to form the corresponding alkene. So the dehydration of alcohol generally taking place in presence of acid catalyst, and the rate of dehydration of alcohol is what? Tertiary is more than the secondary, is more than the primary. Okay, students? So these are the mechanism of the reaction or mechanism of dehydration. Okay, students, good morning to all of you. Myself is Dr. Santosh, Choudhury, editor in chemistry. Last class, that is in class number 6, we will discuss about the method of preparation of phenol. Phenol can be prepared from benzene in so many ways. That is first chlorination, it forms chlorobenzene, and chlorobenzene on fused with NaOH, it forms sodium phenoxide, and sodium phenoxide on acidification gives you phenol. Benzene can on sulfonation gives benzene sulfonic acid. Benzene sulfonic acid fused with sodium hydroxide, again it gives you sodium phenoxide, and this sodium phenoxide on the acidification it gives phenol. Benzene can also convert phenol by the action of propene or propyl bromide. When benzene react with propene or propyl bromide, that is called Friedel-Crafts alkylation, it gives isopropyl benzene, what you call it is cumene, and this when cumene is exposed to the atmosphere, it forms peroxyhydride, and this peroxyhydride on hydrolysis, it gives you phenol and acetone. Okay, these are the methods of preparation of phenol from benzene, and phenol can also be prepared from benzene diazonium chloride. That is benzene diazonium chloride can be synthesized from aniline by diazotization. When benzene diazonium chloride treated with steam, it hydrolyzed to form phenol, nitrogen and HCl. In large scale, the phenol can be synthesized by, that is called Racic process. In Racic process, benzene react with HCl in presence of oxygen. The catalyst is cuprous chloride. It gives you chlorobenzene. Chlorobenzene when treated with steam, it gives you phenol. Okay. Next, the phenol can also be synthesized from chlorobenzene. That is called dose process. In dose process, the chlorobenzene fused with sodium hydroxide to form sodium phenoxide, and the sodium phenoxide on acidification it gives you phenol. Okay, student, these are the various methods of preparation of phenol. You see how the benzene convert to phenol, aniline convert to phenol, that means aniline convert to benzene diazonium chloride by diazotization, and then it convert to phenol. So in various sources you can prepare the phenol, and today we will discuss some chemical properties of phenol. The chemical properties of phenol that is one due to the OH group and other due to the benzene ring. You see, this is your phenol. And the phenol contains two parts. One part is this part is your benzene ring, and this part is your hydroxy group. Okay, so the reaction of the phenol due to some OH group and some reaction due to the benzene ring. And when the reaction of phenol due to the OH group, that the properties are most similar, resembles to your alcohols. First thing come to reaction due to the OH group. The reaction due to the OH group, first properties is your acidic nature. Do you know, according to Arrhenius theory, what is acid? Acid is the species when dissolved in water, it dissociates to form H plus ion. That's called acid. So when a phenol this is your phenol dissolved in water, it dissociates to form the phenoxide ion plus H plus ion. Due to the formation of H plus ion, that's why it is what nature? Acidic in nature. Now you will see why the phenol molecule dissociate to form phenoxide ion and H plus ion. That means we have to compare the stability of phenol and the phenoxide ion. And both the phenol and phenoxide ion stabilized by resonance. That means delocalization of pi electrons to give different probability structures. These structures are known as resonating structure. You know, more the numbers of resonating structure, more will be the stability and stabilized by resonance. But resonating structures of phenol is less stable than the resonating